Part 2. Calculate Pearson's product moment correlation coefficient. Right, a big long wordy mouthful here, but it's simple enough. It's this OR thing, right? And we have the formula supplied to us. OR is the symbol for Pearson's product moment correlation coefficient. So I'm going to dig out the formula now. Where is it? There. Okay. And let's stick it up in the corner here. So that's our formula. So now we need to get a little bit organized with this table. What do we need for the formula? We need the product. You see that summation xy? Well, we need n, right? Let's do n first. N. What does n equal? Well, n is the number of things going on here. We've 1, 2, 3, 4, 5, 6, 7, 8 employees. So n equals 8, right? Another easy one to pick off there, summation of our x values was just the total of all our x values. So we'd add up all these boys here, and that would give us the summation of our x values. And if we add up this row here, likewise, that's going to give us the summation of our y values. Now the other ones here, this summation xy, we need x, that's x times y, right? xy equals x multiplied by y. Oh, so I've just brought in a bit of graph paper there to hopefully make things life a bit easier for organization, you know. So here's our x row, right? So we have 14, 23, 17, 32, 16, 19, 18, 22. So what could we do now? Well, we can do our y row, I suppose. 6, 14, 5, 16, 7, 12, 10, and 14. Now, we need xy in each case, right? xy. So, I need the calculator now. 14 times 6 is 84. 23 multiplied by 14 is 322, right? I'll let you fill out the rest of that now. I'm going to do it, and you can try it. Pause and try them. Right, so I multiplied them out, and you should have got the same results. Like, for example, 16 times 7 is 112. So this is my xy row, and then I'm going to add all these. The summation of the xy's, the product of the xy's, so that all these added up together comes to 1831. Okay, and then I'm going to get the summation of the x values, and the summation of the y values. So have a go. So I just added up there the x's and the y's, and this is what I got. That's the total of our x values, 161, and the total of the y values is 84. Now, what other parts do we need? Well, we have the summation of the xy values, 1831. We have the summation of the x's, 161. We have the total of the y's, 84. X squared, right? So we need to add up. This here is a summation of all the x values squared, but they have to be squared first. So we need a row here of x squared values. So the first one is going to be 14 squared. And that's 196. And the next one is going to be 23 squared. And I got 529. 17 squared is 289. And I'm going to do the rest of them now offline. So there you see I have completed the row of x squared values, and you can see in the formula it's looking for the sum of the x squared values. So the sum of the x squared values will be equal to all these values here in this row added up. And for that I got 3463. And now we can see in the other part of this square root, the second square root there on the bottom there, we have a summation of y squared values. So we're going to have the same idea, same pattern, except this time it's going to be a row of y squared values. So the first y squared value will be 6 times 6, and that's 36. The second y squared value will be 14 squared, and that's 196. The next one then is 5 squared, that's going to be 25. Next up, 16 squared, 256. Then 7, which is going to be 49. 12 12 is 144. 10 by 10 is 100. And then with 14 squared, we get 196. Right, in a similar fashion, for the formula, we're going to need this piece here, the sum of the y squared values. So we're going to add up all this row to get the sum of the y squared values. And I got 1102 there for the sum of the y squared values. So to work out our value, we just place in these little bits into the formula. So our formula is like a fraction, right? We need a big long line. N is going to be 8. And 8 there in the formula is written beside summation xy, so that's multiplied by the sum of the xy values. So I'll open a bracket there and stick in 1831 minus something multiplied by something, and that's the sum of the x values, 161 times 84. And underneath then we're going to have the result of two square roots multiplied by each other. Right, they're written beside each other, which means they're going to be multiplied by each other. In here we're going to have 8 times the summation of the x squared values, 3463. 8 times 3463 minus something squared, right? And the something squared there, you see it, is the summation of the x, summation x, which is 161. So 161 goes there. Similar pattern over here, except we're dealing with y on this side. N is still 8. And the summation of the y squareds is 1902. Sorry about the bad writing there. 1902 minus the summation of the y values to be squared, right? What's the summation of the y values? 84. And we can simplify. Then the top then is going to be 8 multiplied by 1831. 8 multiplied by 1831 minus 161 multiplied by 84. I get 1124 there on top. 1124. Right? And underneath I'm going to get this square root first here. I'll just switch to blue here maybe. Right? I'm going to get this guy first into one number. So I'm going to go square root, and underneath that I have 8 multiplied by 3463 minus 161, and I use the square key. Press return. I get 42.226, right? That's rounded to 3 decimal places. And that's going to be multiplied by the result of the other square root. Okay? And the other square root, use the square root key again. 8 times 1002 minus 84 squared. And it comes up 8 root 15. Press the SD key and I get it into decimal. And I get 30.9. I'm going to round this to 3 decimal places. My calculator says 9838. So I'm going to have 98.984. Okay, and now I can just use a fraction key and go 1124 on top, and underneath I can have 42.226 multiplied by 30.984. Press equals, and I get 0.8591, right? And now I'm going to round to 3 decimal places, so that 1 isn't going to make much odds. So let's see if I can rub that out. Yeah, there. And now I'm just going to get red here, right? That's our answer. That's our correlation coefficient, which looks fairly strong and positive, right? It's not a negative number, it's a positive number. Because our graph, if you put a line through them dots, roughly, it's going like this, right? It's going up the way like that. As x gets bigger, y gets bigger. And that's it. That's a fairly strong, it indicates fairly strong because it's close enough to 1. It's almost 0.86.